Now in this lecture we are going to derive the equations and relations for the rectangular waveguide. As I have previously derived the equations Ex, Ey, Hx and Hy in terms of Ez, Hz. All the fields are now in terms of Ez and Hz. Now first we are going to start for TM wave. TM wave is transverse magnetic wave. Transverse magnetic wave is the transverse magnetic field component is 0. Our transverse magnetic component is in z direction, and for this case Hx, Ey, Ez fields exist. Now let us start the derivation. Now we always start with this equation. Del square E is equal to minus omega square mu epsilon. Now this del square, as I said, is Laplacian operator that can be written as dou square by dou x square of the field plus dou square by dou y square of the field plus dou square by dou z square of the field. Now I have already said that dou by dou z can be written as minus gamma. Dou by dou z is minus gamma. So whole square of this will be whole square of this. So gamma square. And we also have the relation gamma bar square plus omega square mu epsilon is equal to h square. Now using this relation we get this equation. So now let us group the terms. That is, let us say grouping both these terms and equating and assuming it to be a square, and the other term will be minus a square because the whole should be equal to 0. So now from this equation you can the solution of x will be x is equal to c1 cos bx plus c2 sin bx, and y will be c3 cos ay plus c4 sin ay, and here actually you have a but you have written b, so we have to write b square equal to a square minus h square. So now let us assume Ez to be x into y. So multiplication of both these. And I have already said there are boundary conditions. Now you have a rectangular waveguide like this. That is, you have plates in the x direction and also plates in the y direction. So you have 4 boundary conditions. You have boundary conditions at x equal to 0, x equal to a, y equal to 0 and y equal to b. We know that at the boundary the electric field, the transverse electric field component should be 0. That is, now applying the first boundary condition, x equal to 0. When we apply x equal to 0 in this equation, you will obtain this. That is, sine 0 is 0. So this term goes. And now you have c1 cos of 0 is 1. So c1 into c3 cos ay plus c4 sin ay. Now because this complete thing can't be 0, this should be 0. So we know that c1 is 0. So now when you substitute c1 0 here in this equation, you will get c2 sin bx into this term. So that is what I have shown you. That is what the field obtained here will be c2 sin bx into c3 cos ay plus c4 sin ay. Now the second boundary condition is at y equal to 0. When you apply at y equal to 0, then this will be this equation. You should always substitute in this equation. So it will be, the first term is c2 sin bx into, in this equation, when you substitute y equal to 0, that is sin y goes 0, and now you will have only this term. So c3 cos ay. Cos ay also cos 0. So this is 1. So the term left is c2 into c3 into sine of bx. Now because c2 can't be 0, because if c2 is 0, the complete x component will be 0 and the field doesn't exist. So here only C3 should be 0 for this equation to be equated to 0. So now you assume C3 is 0. So the remaining equation is C2 sin Bx into C4 sin Ay. That is what is left here. Now you have to evaluate what are A and B, because those are also the constants that we assumed, and we know that B square plus A square is equal to H square from the previous relation. So now applying the third boundary condition, that is x equal to A. Even at x equal to A, Ez field should be 0. So from substituting in this equation, you have C2 C4 sin Ay into sin Ba equal to 0. Now this is always constant. Both these constants C2 and C4 should not be 0, because if C2 is 0, x will be 0, and if C4 is 0, y will be 0. So neither of them should be 0. And either sin Ay should also not be 0. Now sin Ba should be 0. For sin Ba relation to be satisfied, Ba should be equal to n pi. Let us say m pi. So B will be equal to m pi by A. This will substitute later. Now you also apply the fourth boundary condition, y equal to B. That is Ez is equal to C2 C4 sin AB sin Bx. Already we have evaluated B. Now similar way, sin AB equal to 0. So AB equal to n pi. So this B will be brought up here. A is equal to n pi by B. You are substituting these here and you get this relation. Now that we have got Ez, we have to evaluate the other existing fields, that is Ex we have to evaluate. We have already known this relation. We already have another term here, but which involves Hz. But Hz is equal to 0 in this case, so we don't have that term. So minus gamma bar by H square into dou Ez by dou x. Dou Ez is already there. Ez we are bringing it here. So minus gamma bar by H square into dou by dou x of, that is C2 C4 come out, and you are differentiating this term. So it is n pi by A comes out, and that will become cos n pi by A into x, and this term remains as it is. So now you have evaluated the term Ex to be this one. Ey is similarly evaluated, and Hx and Hy. Now we are going to derive the other relations here. That is, we know the relation A square plus B square is equal to H square, and H square is equal to gamma bar square plus omega square mu epsilon. Now gamma will be written as under root of H square minus omega square mu epsilon. But H square is A square plus B square, and A is m pi by B, and B is n pi by A. So put it here, that is under root of H square is A square plus B square minus omega square mu epsilon. Substitute these here and you get the relation. Gamma bar is equal to root over n pi by A whole square plus n pi by B whole square minus omega square mu epsilon. This is the relation. But we know that gamma bar is alpha bar plus j beta bar. The propagation exists only when alpha equal to 0 and this gamma is imaginary. So we can write it as j beta bar is equal to j into root over omega square mu epsilon minus n pi by A whole square minus n pi by B whole square. This j and j gets cancelled. Now beta bar is under root of omega square mu epsilon minus n pi by A whole square minus n pi by B whole square. And the other relation that you can derive is the cutoff frequency. The cutoff frequency can be written as 1 by 2 root mu epsilon into root over n by a whole square plus n by b whole square. And you also know there is a relation between lambda and fc, that is 2 by root over n by a whole square plus n by b whole square. And we also know the velocity of propagation can be written as omega by beta. We know beta from the above relation. So omega by root over omega square mu epsilon minus n pi by a whole square minus n pi by b whole square. This is what we have derived.